paired forces can be reduced to what we call a couple, or an applied moment, or a moment. So the requirement is for a pair of forces that these forces must have equal magnitudes but opposite direction. And when that's the case, we can simplify the pair of forces into just a couple. Now, like we saw for taking the moment about a point, there are two methods to do this, one that lends itself better in 2D typically, and then the vector method, which really we have to use when we're in 3D. When we're in 2D, we can use the scalar method, which looks a lot like taking the moment about a point. We can take the magnitude of each force in the pair, since they're going to have the same magnitude, that's F, and then multiply it by the perpendicular distance between the forces. When we are using the scalar method, we have to be aware is this pair of forces going to be causing a clockwise or counterclockwise moment or rotation of our object. And again, that will give us the sign then that's appropriate for the value of C, which is what we call the couple. Using the right-hand rule, just like taking the moments about a point, a counterclockwise rotation is going to result in what we consider a positive moment or a positive couple, and a clockwise rotation is going to result in a negative couple. Now, this couple is going to be acting around typically that z-axis, and that's why we can represent it as a scalar, but really it's a vector that only has a value in the k direction, if we're using a typical x and y plane for our scenario. If we're in 3 dimensions, or if finding that perpendicular distance is particularly difficult in 2D, we can use the vector approach as well. So here, there's two ways we can do it. It's going to be an r cross f, like we saw for taking the moment about a point, but here the position vector is going to point from any point that the second, what we're calling the second force vector passes through, to any point along which the first vector passes through, crossed with the Cartesian components of what we're saying is the first vector. Now really in this context, the first vector is whatever the end point is of the position vector. Now we can also go the other way and point from any point on the first force vector to any point on the second force vector, which we'll call R12, and cross it with what we're saying is the second force vector. But once again, the end point matches of the position vector matches what we're calling the second vector. And if we use this vector approach with the cross product, the signs are automatically going to come out for us for clockwise versus counterclockwise. And here, the couple is going to be a vector. It should have I, J, K components. So what we're going to do is when we reduce a couple of forces into what we're calling a couple or moment, we can represent it on our figure, on our free body diagram, as either a rounded arrow indicating the direction of the twisting, clockwise or counterclockwise. And typically in 2D, this is a good way to represent the couple, or as a double-headed arrow, which is pointing along the axis about which this couple is acting. And oftentimes in 3D, this is going to be a better indication about the direction of the couple, as it can be confusing to look at the rotated arrow of, is this really representing a clockwise or counterclockwise twist? So what we're doing when we reduce our system, we are getting rid of the pair of forces and replacing it with the couple, which is really the net effect they're having on our object, that net rotation. So it also is going to simplify the equations that we write. When we reduce the system to just a couple, we now don't have to compensate for these forces when we are summing forces in any direction. Now, if we didn't reduce it to a couple, we would find out that those forces just cancel each other out anyway, because one force has as much in the x as the other one has in the negative x, and one force has in the positive y the same amount that the other force had in the negative y. So in the force equations, they have no net effect anyway, they cancel each other out. However, the couple, or the twisting that they produce, will come to light in the moment calculation that we make. When we are taking the moment about a point, what we need to account for and be careful of is that we are counting every force that acts a distance away from that point, as that's going to produce a moment about that point, and we need to account for every couple in our system. But two things on that. the couple is going to be counted no matter where it's acting in our system, even if it's acting at the point we want to find the moment about. And this is related to a couple is already a moment. We are never going to be multiplying the couple by a distance. However, the forces do get multiplied by a distance because that is the moment produced by the force. The couple already has this built in, so the couple value directly will go into our moment equation. Again, we'll have to be aware of should it be a positive or a negative contribution around the point in question. Now, why are we counting the couple no matter where it is in the system? We have to think about that. Is that externally, the location of the couple doesn't matter. It's going to be counted exactly the same in that moment calculation. When we start talking about internal forces at the end of this class and in the strength and materials class, now the exact location of that moment is going to matter when we are considering internally what's happening. And a last note on couples, the wording is going to be a little bit confusing here, especially the way I use it or many textbooks use it. When we are finding a couple, we might also refer to the couple as a moment or a couple moment or an applied moment. Note that this is different than taking the moment about a point. That is going to be a calculation involving all the forces that are a distance away and any couples or moments that are in the system. So the term moment is kind of overloaded and it can be confusing, and in notation-wise in equations it can be confusing as well. But just make sure that in your mind you are separating what is a couple or a moment versus the moment about a point or the moment about an axis.